Right, so today we're going to look at functions. So this is in the GCSE paper. Again, it's higher level, but the first part of it is very straightforward and very accessible. So we're going to be looking at functions, which is in the higher level GCSE paper today for maths. So all a function is something that gives you a rule of how to put something in and get something out. When you were at primary school or lower down the school, you would have seen things like number machines. So it kind of works like that. So if you've got an input, so you would have input something and you'd get something out, but we're going to now input an x, and it's going to go through the function, and the function does something to it, and we get our output. So if we say our output in this case could be 3x. So this would be our input. And the way that we would write that is f(x) equals 3x. And now that could be a g, they could use any letter. It's just kind of a fancy way of writing even y. You could have, so f(x) equals 2x. So the name of the function is f in this case, and the input is an x, and the output is 3x. So what does that actually mean? So let's take another example. Let's take f(x) equals x squared plus 1. And I've got to say, what is this function doing? So I'm putting that x in, which is the input, I'm squaring it, and I'm adding 1 to it. So for example, if I was going to input the number 2, what am I doing to that 2? I'm squaring the 2, so I'm doing 2 squared, which is 4. Then I'm adding 1, and it's giving me 5. So all I'm doing is I'm putting something in, and what do I get out? Exactly like an equation, but it's fancily put as a function. So if I had f of a minus number, now this is really important. A minus number squared is always positive because you've got minus times a minus, which gives you a plus. So minus 3 squared would give you 9 plus 1, which would give you 10. So that's what a function does. So if you change the input of a function, all you do is replace the thing where the x is. Now we've done that with numbers. Now what if I replaced it with a letter? Exactly the same thing. So if I look here, the input was the x. I'm now changing the input to an a. So wherever there's an x in this function, I'm going to be writing a instead. So I'm going to get a squared plus 1. So now what if I had f of 2x? Wherever there is an x, instead of the x, I'm writing 2x squared plus 1. So that would give me 4x squared plus 1. So that's all a function is. It's just inputting whatever you have as the x. So let's take a few examples of just this first bit and how they've tested it in the last few years in exam questions. And it's come up in all the GCSE exams, the high level exams, because it's something new. So for example, if we take, so this is from the an AQA paper, we've got f(x) equals x squared plus 3x minus 10. And they've said to you, show that. So show that's a nice when you get the answer, but they can be frustrating when you don't. f(x) plus 2 equals x plus 7. So you're now looking at what's the connection from this bit to the second bit. So let's have a look. We've got x here and we've got x plus 2 here. So we're going to input wherever there's an x, instead of that x, we're going to replace it with the x plus 2. So instead of this x here, we're going to put x plus 2. So we're going to get x plus 2 all squared. Instead of the x there, we're going to replace x plus 2, and we'll get minus 10. Now we're going to open out those brackets. So when you open out x plus 2 squared, you can square the first number. If you need to write it like this, by all means do. But whenever you have something all squared, a shortcut way to do it is you square the first term, x squared, you times the two terms together, so x times 2 gives you 2x, and you double it to give you 4x, and you square the last term. And then we're going to open out these brackets as well. So 3x plus 6 minus 10. When I clean that out, I've got x squared, 4x plus 3x, which is 7x, 4 plus 6, which is 10, minus 10, which is 0. I can take x outside the bracket, and I've got the answer there. So there's one type. Let's take one from the Edexcel paper as well. So there was a similar question. This was from the specimen set, and it was towards the end. It was a question 18. That it's aimed at sort of the higher bits. We'll look at composite functions and inverses in a bit, but let's just start here. So then we've got fx plus 2. Wherever there's an x as my input, I'm replacing it with x plus 2. So what we get is 3 x plus 2 all squared minus 2 x plus 2 minus 8. Now, if I was to open that all out, I get 3 x squared plus 4x plus 4 minus 2x minus 4 minus 8. So that gives me 3x squared plus 3 times 4, 12x plus 12 minus 2x minus 4 minus 8. 3x squared is on its own. 12x minus 2x is going to give me plus 10x. 12 minus 4 gives me 8, minus another 8 gives me 0. So there's no numbers there. And that would be it. If I wanted to factorize it, I could, but the question actually asked for it in the form ax squared plus bx. And if your writing gets messy and all over the place and you think you might have not have made it super clear to the examiner what your answer is, underline your answer or write a equals 3, b equals 10. So make it super clear that you know what you're doing. So that's the basic part of functions. And like I said, difficult topic, but this bit of it should be quite straightforward. So you've got your function, which is essentially just churning something out. So it's what you put in, an input, which gives you the output. So now we're going to look at the inverse. So we're going to have a look at inverse functions, which essentially, I cannot spell. Let's do that again. Let's take 2. So an inverse function, which is essentially the opposite. So an inverse function does the opposite. So an inverse function is you're putting something in. So say I put 2 in, and I don't know, my function was to times it by 3, my output would be 6. So that's my input. Now, if I was to go backwards, I'd be doing the opposite. I would be dividing by 3, and I would get 2. So if we've got, sorry, I've got a question here. How many marks are they worth? So they can be worth anywhere between 4 and 6 marks. You don't need to write that in the end. If you've learned to do that, that's really good practice, but you're not going to lose any marks if you don't. If you don't write QED, or even if you do sort of like a hashtag sign at the end. Right, so we've got an inverse function. We've got input, we're inputting 2, and we've got something out. So now in the same way, if I was going to have my fx, and I was going to write this function in terms of x, I'm inputting the x, and in this case, I'm multiplying it by 3. So my opposite of that would be taking my x and dividing it by 3. And the way I represent an inverse is this weird symbol, which is the -1x. So if you think of like your calculator when you do inverse sine or inverse cos, so think of it like that. It's an inverse, so you represent it with a -1, because you would use sine to the -1 to do your inverse trig functions. So that's an inverse function. Now, obviously, this is quite an easy one. We had 3 times, so to do the inverse of it was quite straightforward. But to do, so if you're doing a full method for an inverse, so we'll take a few which are super straightforward and you should be able to do in your head. So let's take, for example, fx equals x plus 5. To do the inverse of that, well, we're saying in one of them we're adding 5. So the opposite of adding 5 is obviously to take away 5. If I had fx equals 6x, well, we're timesing by 6. So the opposite, the inverse of it, is to divide by 6. So we'll have x over 6. But now let's take one that's a little bit more convoluted and write out the full method. So if I had a full method and I had fx equals, let's say, x over 6 plus 4. Okay, and I want to find the inverse. Now, because I think it's easier, I would just change the fx into a y, because it's just for convenience and you're not writing fx and trying to rearrange. Then because you've all done changing the subject of the formula, you're now going to change the subject of the formula from being y to being x. Now, some people get confused and halfway through go back to y equals. If you think you would do that, then swap your x and y at this point and rearrange it for y. But we're going to change the subject of the formula and make x the subject. So that would be y minus 4 would leave me with x over 6. So x on its own is 6 lots of y minus 4. So just move that down a bit. Okay, so we've got x equals 6 lots of y minus 4. So now I can say my inverse f to the minus x equals 6. And instead of y, I've got to put an x there, x minus 4. And that would be your full way. You've got to make sure you swap your x and y. So let's take a couple of difficult or tricky ones. So these each were worth, let's have a look, they were 4 marks. One of them was 4, one of them was 5 marks in the exam. So we've got f of x equals x plus 1 over x minus 2. So my first step, like I said, was I'm going to make the fx into a y to make it easier to manipulate. And now I want to rearrange it to make x the subject of the formula. So I'm going to multiply up the x minus 2. I'm going to open out my brackets. Yx minus 2y equals x plus 1. I'm trying to make x the subject, so I'm going to put all the x's on the left. Yx minus x equals, I'm going to move the y over as well in that same step. So I move the 2y. I'm going to take x outside the bracket and factorize that bit. And then I get x equals 1 plus 2y over y minus 1. And now if the please don't forget this step. It's really, really, really important that you then write f to the minus 1x and change the y's into x's. And that would be full marks. And I know it's a little bit trickier and they require practice. But again, like I said, these are level 8-9 questions. So those are finding the inverse of a function. Next bit is composite functions. So a composite function is putting two things together. So remember we said it doesn't always have to be an f, it could be any letter. So we're going to have an fx and a gx because that's typically what's used. Right, so when we have fgx, what we're actually doing, so if I was going to write what is fg of 2, what I'm doing first is I'm doing, it's like having a bracket here, and I'm doing g of 2 first, meaning I'm putting 2 inside of g. So when I do that, I get 2 squared, which gives me 4. So actually, I can replace that with a 4. And then I'm putting 4 into the x of f. So I've got 3 times 4 plus, so no, I'm writing up. 3 times 4 plus 1, so 12 plus 1, which gives you 13. So because fg of something means f of g of 2. So this is saying f of g of 2. So you start with the innermost one. So we always input from right to left. So because that's the way we apply the functions. So let's think about it algebraically now. So, and that's usually how they're tested. So let's take some functions. Let's take fx equals 2x plus 1, and gx, they like to do the 1 over, so let's do 1 over x. And if we have fgx, what we're saying is we're putting the whole of g into f. So I'm actually doing f of the whole of g, which is 1 over x. So I'm replacing this x here with this. And then so I would get 2, 1 over x plus 1. So that's just 2 over x, because 2 times 1 is 1. This is just like fractions, plus 1. And that would be my final answer, which is different from gfx. So now I'm putting f into g. So it's the same as g 2x plus 1, which would just be 1 over 2x plus 1. So some other things we can do with that. So if we keep those same functions, doesn't want me to delete, okay. Let's rewrite them. fx is 2x plus 1, gx is 1 over x. So if we had f of x, so that's saying I'm putting f back into f. So all I'm doing is I'm replacing that with 2x plus 1, which would be 2 lots of, wherever there's an x, putting 2x plus 1, and then I've got a plus 1, because I've just replaced that, is that, and that would give me 4x plus 2 plus 1, so 4x plus 3. And similarly, you could do something with the g's. So those are the different types of composite functions. And that takes you through the end of the GCSE functions section. Beyond that, this extends a little bit further if you're doing any IGCSE further maths, where you then get to do things which we call like domains and ranges and lots more sketches, thinking about functions. But as far as GCSE maths goes, the bits that you need are you need to be able to understand what a function is, calculate inverses of functions, and then do your composite functions. So let me pick out, see if I can pick out any more GCSE questions. So let's take one more exam question. So if I said, all right, the diagram shows y equals fx. So it tells you the function f of x equals 2 over x plus 1, g of x equals x squared minus 1, and it's asked for fgx. So what we're doing is we're putting g inside of f. So I would always start off, so you don't confuse yourself and don't try jump steps, is write the f out, then put whatever g of x is in its place. Because then you won't forget, because if you know when it's a number, that's what you do. You can do that with a composite function as well. So we're going to say 2 over x squared minus 1 plus 1. Minus 1 plus 1 cancels out, and we get 2 over x squared. And that is essentially functions. There's not any much more to that. And it is always question 15, 16, 17. So towards the end of the paper. Somebody's asked me, can you explain it again? Okay, sure. We've got a bit of time, but this is the last bit. So let me just go through a composite function again. So a composite function, in summary, is So if we had, let's take the same example we had with 3x plus 1, and we had gx equals x squared. If I wanted to do fg of 2, essentially what I am saying is I'm saying it's the same as f of g of 2. So first I do g2. So I do this bit first. So I put 2 into my g. So g2 would be 2 squared, which is 4. And now I can replace that with a 4. And that's the same as 3 times 4 plus 1, which is 13. So that's it with numbers. When I'm looking at a composite function algebraically, if we take the same thing we just did, but we look at it algebraically, I'm doing fg of x. It's the same as saying I'm putting the whole of g of x into wherever there's an x in the f. So it's the same as f of x squared. So now wherever there's an x, I'm replacing it with x squared. So I get 3x squared plus 1. Whereas gf of x is taking the whole of this and putting it in g. So it's g of 3x plus 1. And what is the function g? This confuses people. People get this wrong. G is saying I'm taking something and I'm squaring it. Now in this case, my something is 3x plus 1. And so it's 3x plus 1 all squared. So I hope that sorts that out. How is G2 4? Because I replace the x with a 4. So your input is the x and your output is the x squared. So if you input 2, 2 squared, which is 2 times 2, would give you 4. Right, so I hope that makes sense, and I hope that was useful. I will be doing a bit of chemistry in about 10 minutes if you want to join back then. I'm looking at some more calculations, which we didn't quite get to the end of last time.